that that ball for sure entirely lies within the set or within the set NR, its neighborhood of P. What do you think that what should be that? Should be less than R. One thing is always that, okay, whatever radius I must choose for this
R minus
R minus what?
rho
P to R minus.
What is rho?
that's another radius.
Just think physically about it. Don't worry. Don't get into too many symbols. So I want to draw a sufficiently small ball on this Y in such a way that ball lies within this ball.
Distance between P to X minus Y to X.
Is going to give me what?
Radius of the Y, sir.
R by 2.
Huh?
R by 2.
R by 2. Is it necessary that this point is at a distance half, okay, from point P? No, it's not necessary. It could be greater than half, less than half, could be anything. So another thing which is going to
R minus Y minus P.
R minus Y minus P.
Last one is
मतलब Y minus P.
So first of all, we need to realize that this distance between P and Y is going to play a crucial role. Okay, this distance between Y. So set A as a distance between P and Y. Okay, set this distance as P and Y. Why I'm giving it a name?
So we don't need to give it.
Okay, don't need to give it a name actually. So let's take, yes, what should we do then next?
बराबर होगा किसका?
We must take, sir, R minus P and Y minus P.
What is R minus P?
P to X, sir.
Or distance
P to X,
from
sir,
R
Y.
to B.
So, do we denote it by R minus P?
No, sir. This norm, sir.
Okay, no, not meter gap.
Yes, sir. Meter, sir.
Okay, the metric distance.
Yes, sir. And there is a difference, sir.
Okay.
Or
What should I do? R minus.
Uh,
So this number is what? You are giving me a number. Okay, a new radius actually. So let's call it R prime. Okay, and this R prime is what? That from this total distance which is R, subtract out this distance. It's going to give me this distance. And we say that if you basically draw a neighborhood of this small distance, that is, if you draw a neighborhood of small distance which is smaller than basically this distance, you're going to say that a ball drawn of that radius is going to entirely lie basically within that ball. Okay, so R prime should be what? R minus
R minus R.
D
R minus Y minus
P minus
Distance.
Y
P.
P Y
P.
okay.
P to Y.
Okay. Shall I choose equal or
Less than. So we should set it equal. Then we would
let us choose?
we should take it as equal right now. Then we will take it smaller neighborhood. We exclude this R in when we take the neighborhood. So let's make it equal right now.
Okay, let's make it equal. And let's listen to what we is saying. Next, what we do?
When we choose a neighborhood at R, neighborhood at Y, we will definitely exclude this R because neighborhood will be open. So this R will be taken out again.
So what should I do next?
Now draw any neighborhood at Y.
Okay, so let's draw a neighborhood. Consider, whenever we say that consider what a neighborhood
Of R prime radius at Y of radius R prime.
prime. Okay, and your claim is that this is entirely contained in
N.
That's what your claim is. So we need to prove it. Okay. So in order to show this, so if this is really entirely contained in N, this is going to show that Y is an interior point. Is going to show that going to show what?
Y is an interior point.
Y is an interior point of A, but did we took, yes,
Yes.
we took the Y basically. Okay, we took the Y and we shown that Y is an interior point of N.
Yes, sir.
So in order to show this, what we should do? So my claim is that choose this radius and draw a ball around Y of this radius is going to be always contained in M. How should I prove it? So I need to take an element from there. I need to show that it should be here actually. So let's take T a point from N of R prime of Y. Okay. So what does it immediately gives? So in other words, I'm saying that I'm drawing a ball around basically this point Y of radius R prime. Okay, and I'm taking a point T in from it. Okay, small point T from it. So if T is in R prime Y, what does it mean?
Distance between
Distance between
T
T
and
and Y is less than
R prime.
R prime. So how does this is going to help us?
Which is equal to,
Less than R.
So R prime is
Less than R.
it less than?
no, it's equal to R
Is
minus.
equal to R minus
Distance between P and Y.
distance between P and
Y. Y.
P and Y. Okay. What should I do next?
R is equals to, no. Distance between T and Y plus distance between P and Y.
So as you are saying that take this basically object to another side. So you're gonna have distance between T and Y
Plus
plus distance between P and Y, or Y and P doesn't matter.
is
Is
less than
R.
R.
Okay. So how this is going to help?
Triangular inequality.
So we have triangle inequality that this guy must be always bigger than or equal to distance between
P to T.
P and P. So what you just shown that
It's in
distance between T and P is less than R. So if it is basically the distance between T and P less than R, then this T must be in
N.
this M. In other words, this neighborhood of P. So this is entirely contained in M. So what does it show? It shows hence Y is interior point of N. Okay. So I took an arbitrary point from Y and I shown that it's an interior point of P. So what is it going to show? That N is open. Thus, N is open. Okay. Is it making sense? So I mean, if you keep this picture in head, it's really much logical. And this result is so powerful that it's true for all metric spaces. No matter what metric space you have, always a neighborhood is going to be an open set. Okay? You take a neighborhood of a point and any metric space is going to be always open. This is something that you are making a claim and it's true in all metric spaces. Let's move ahead. Next that I would like to do is a picture. Begin with it. Let me draw a picture here first and I'll keep it as it is and then. So we know that if I have a point is a limit point of E, if and only if, what would be the characterization of it by definition? That you draw a neighborhood, any neighborhood on P with any radius, okay, and you remove P out of it, in other words that's a deleted neighborhood, then its intersection at point E
Is not null.
is not happening. Okay? That's what the definition is. Alright? Now, wouldn't that be an interesting question to ask that, okay, they are going to meet at many points. At how many points? Is that going to be just 1 point? So in other words, let's try to quantify that what is going to be common between these two sets. Okay? Is that going to be 1 point?
Or neighbor.
Okay, you need at least 1 point to show that. Okay? You need at least 1 point to show that. If you show that, okay, this intersection contains 1 point, you are done. Okay? But is it going to contain only 1 point or 2 points or finite number of points? Okay? Or infinite number of points? So let's try to think about that. So what we are saying that I have a set E, okay, and I take a point, basically really say just on above boundary or something. I can take it inside and take it outside as well. Doesn't matter. Okay, really just above boundary or on boundary. Okay, can't be above, because if it is above, you can find a neighborhood which is going to not intersect. So we're going to show soon that either a limit point should be in E or should be on boundary. If there is no other way, you can have limit point.
Either interior or boundary.
Not interior, because if it is on boundary, it's not interior.
No, either interior or boundary.
Or boundary, or you can have several other characterizations. So what I'm saying that imagine I'm saying that I've drawn a neighborhood, an arbitrary neighborhood of this point, and it intersects with the, say, finite points of this, basically. Finite points of this, set. Okay. For example, say I take 1, 2, 3, say 3 points. There are 3 points where they intersect actually. Only 3 points. And nothing else. Okay? Now, why this would be a troublemaking thing? You need to keep this thing and there's bit more, this involves this. This picture gives an illusion that there are lots of things, other commons other than 3 points, but we need to just assume that it's only these 3 points where this neighborhood and set E are meeting. So if there are finite number of points, say 3, common between this neighborhood and set E, then why this is a kind of a troublemaking thing? Can you see a trouble if you only assume that there are finite elements common between both and nothing else?
Means we can have a radius, sufficiently small radius.
What would be that radius?
That will be contained and
Walid, क्या होगा?
Sir, we can draw a neighborhood on that point with some certain radius that would not contain these 3 points. That would eliminate these 3 points. Hence, P would not be a limit point.
That is going to be the trouble. So in other words, if I take this point and compute a distance between this and this and this, and I take a minimum of these 3 distances, and I draw a radius which is smaller than this minimum, that is, this neighborhood is not going to contain. So this is the kind of a neighborhood of P, but is not going to contain, these 3 points are not going to contain any point of E actually, and hence this would not be a limit point. A contradiction actually. You getting the point? Contradiction. So in other words, if a neighborhood, an arbitrary neighborhood of a point is intersecting with E, it should not intersect only at finite points. There will be always infinite points actually. Okay? So, if you have understood this picture, I'll write a theorem and the proof we have already done in the pictorial way as well. So I'll just put it in an argument sense. Okay? It's really beautiful when you play with these pictures. Okay? Pictures are good. Pictures are sometimes misleading, so be very careful about pictures. Okay? So here's a little theorem which says that if P is a limit point of set E, so I'll I'll rewrite it directly. I will say that if P belongs to E prime, where prime is a notion for
limit.
limit point, okay, then every neighborhood of P contains infinite many points of E. Can't be finite actually. Okay? Okay? So we're going to say suppose contrary. The best would be that okay that I want to show. So let's write it that P is a limit point of E and N, which is kind of NR of T, a neighborhood of radius P. Okay. Be a neighborhood of P, and suppose contrary. Contrary that when you intersect N with E, it contains finite points, distinct finite points.
A1, A2,
So for example, those are say A1, A2,
up to A.
like this picture. Okay? Okay? So what should I do? I would say choose a radius. Huh? Choose a radius. Keep on guiding me. Huh? What radius should I, what name should I give to this radius? Let's give it name
Instead of between.
R prime.
R prime.
Because I've used already R. And R prime is what?
This minimum of
It's a minimum
Distance
of the distances between P and AI, where I belongs between
1 to N.
Okay? And our claim is that if you take this N prime and remove P and you intersect with E, okay, should be empty. Okay? So, think for yourself, let's see why this should be empty. So try to prove it rigorously that why this should be empty. So you're going to assume, suppose it's not empty, so there must be a point. And why that point would be a troublemaking point. So think about that actually. Okay? Think for yourself. ठीक है? Is it making sense? Let's think about, imagine that's my meeting space X. Let's get to the next one. Let's do these results pictorially first and then try to write a proof. That's my meeting space. And I'm taking an open set here. In other words, so I'm not using reference of boundary, so here actually. Well, I'm saying that all points are interior points of this basically open set. Okay. What you can say about E complement? If E is open, what would be E complement?
E is a subset of elements.
E is a subset of obviously X. E complement is also subset of X.
X is a universal set.
X is a metric space, universal set. Okay? And E complement means X minus E actually. So, what you can say about the nature of E and E complement?
E complement is open.
E complement should be open as well. So if E is open, E complement should be open. So it should be closed.
Be closed.
Okay, some people say that it should be closed, and some people say that it should be open. So roughly, just think about it. If this boundary is not included in E, then where it should be?
Yes, sir. Complement.
Complement actually.
The boundary को तो हम
We're not giving reference of complement.
Yes, sir.
Let's not talk about that. And I want to prove, basically what I want to prove? I want to prove that if E is open, then E complement is closed. And if E complement is closed, then E must be open. That's what I would like to show. Okay? I would like to show this pictorially first and then try to write the proof. Assume that E is open. So the next theorem is that E, which is a subset of X obviously, is open
If and only
if and only if
E complement is closed.
E complement is closed. Okay. Let's try to think about pictorially first and then try to write it realistically. So imagine I'm assuming that E is open. And I want to claim that E complement is when a set is closed.
When it's all points are limit
limits
points.
points
All limit points.
are
All points are
Limit points.
all limit points contain
all limit points are contained in E.
And
Okay, so it's like a set E is closed if it contains all of its limit points. Okay?
any का सूत्र है.
It contains all of its limit. So why do you think that E complement is going to contain all of its limit points? So imagine, so obviously I can't have a P here because this would be outside meeting space, okay? So P has to be in two places actually. So either P is going to be here,
Inside E.
okay? Or P is going to be, on these dotted points.
among
Any point. So it's like any limit point, if I say that P is a limit point. So there are three places where this limit point can be basically live. Okay? So either it can be within E complement, or on this dotted line, which also means that it should be in E complement because this dotted line is not included in E actually. Okay? Or it can be inside E. Okay? That will be 3. So can any point which is inside E can be a limit point of E complement? Let's think about this actually. Can any point E is going to contain all of its? Shouldn't be actually. The draw ball is not there, so that's not an interesting point. So I can only find limit points either here or here. So it can't be away from this dotted line. I mean, if you make it away from this dotted line, that's a troublemaking thing actually. That's not going to intersect with E complement. Because the neighborhood of limit point of E complement should intersect with E complement. So if there is something, okay, in E, you draw in E and it intersects with E complement, that would be a miracle, because you you found such a points which are in E and outside E as well. So it's like both actually. So non-empty intersection of. So it could be here. So if it is here, what does it mean? I can draw a ball, okay, which intersects with E complement at loads of points actually. And how about if I have this P on this dotted line? It also means same actually. That if I draw a ball around it, so it's going to contain loads of points. Can this point be inside E? So we're going to say that it can't be inside E. So if this point is, maybe the better way to argue is not to think about these 2 points, but think about, can a point which is inside E be a limit point of E complement? The answer is no. If it is not, then where it could be?
E complement.
If P can't exist, it should be in E complement. So in other words, all limit points of E complement must be in E complement. They can't be in E actually. So that is going to show that E complement is closed. How about the other way around? So I think that, so if E complement is closed, let's assume that E complement is closed. I would like to show that E is open. So what I need to do, I need to take a point from E,
And show that it's
okay,
interior.
and we need to show that
It's interior.
interior point,
It's an interior
interior point
of
of E. Okay. So that
all
one
points
is,
should be interior, so arbitrary
why if I take a point from E, it should be in interior of
by definition of
why definitely. That's what we need to prove actually. Not apply definition actually.
No, so by definition we have seen that if every point is interior point, then set is open. So if we pick arbitrary point and show that it's open, then E will be interior, then E will be open.
How about giving this argument? Just think about it. If I take a point from E, then E cannot be a limit point of E complement. Why? Because E complement is closed. Then it contains all of its limit points. So this can't be a limit point of E complement. So if it is not a limit point of E complement, that means that there must exist a radius in such a way that if you draw a neighborhood of that radius on this point is not going to intersect with E complement. So if it is not intersecting at any point with E complement, it should be
Entirely.
entirely contained. This would be kind of a Victorian that actually. ये abstraction सीख लें, ठीक है? This is something fun बेटा. Okay? There is no escape from this. ठीक है? So we are taking an intuition and then writing a proof. ठीक है? One of the troubles that when we were learning these things is that we were not getting these pictures actually. So it's time to realize all these things. Anyway. So let's do this way. Let's do this way. What does it mean?
E is open.
Is open. Assume that E is open. So we claim, we need to show that E complement is closed, right? And in order to show that E complement is closed, what I need to do, I need to take a limit point of that E complement. Okay? So let P belongs to what? P belongs to P is a limit point. P belongs to E prime actually. Like,
P.
okay, let's say P is the limit point of E complement, rather than saying P belongs to E complement prime. P is a limit point of E complement. So if it is a limit point of E complement, okay, then where this P could be? So there can be only two places.
Either in E or
Either it's
E.
going to be in E or in E complement. There is no in between. Okay? So we are going to assume that suppose it is not in E.
No, sir. Will
Suppose it
not
is
be in E because every point of E will have its neighborhood will be in E. So there will be no intersection with E complement, so it must not be in a limit point of E.
This will be an argument.
So I just assume
Which theorem?
that if it is E is open, sir, then every neighborhood, every point which is in it will have a neighborhood that will be entirely in E.
Why?
So
Because E is open.
because E is open.
Okay, then,
So it will not be a limit point of E.
E complement.
okay.
Your argument.
So tell me that what should I write? Okay. Okay, tell me what should I write? I want to write this what you are describing. Okay.
X cannot be in E because this argument.
Okay.
Thus X belongs to E complement.
I mean, I want to write it.
Either P can be.
Okay, so we're gonna say that either P belongs to E or P belongs to E complement. Okay? So we're gonna show that P belongs to E is a troublemaking thing.
So we must give the reference that